Hi guys, welcome to this screencast on biomechanics, specifically looking at analysing movement through the use of technology. So technology specifically in today's lesson. So what we need to be aware of is we need to know definitions of what is limb kinematics in biomechanics, what are force plates and what are wind tunnels. We need to be aware of how each type of technology may be used to optimise performance in sport, specifically looking at advantages and disadvantages of these pieces of equipment. So first of all, exam questions you may get on this type of question in biomechanics. First of all, the top one, 2 marks, describe how limb kinematics can be used to enhance performance in sports. And then looking at this other question, explain using practical examples how force plates are used to enhance sporting performance. So at the end of the lesson, we should be able to answer both these questions as well as some others that we have for you. First of all, we're going to be looking at the first kind of biomechanical technology used in sports to enhance sporting performance, and it's going to be limb kinematics. Okay, so looking at limb kinematics, we need to know definition, how it's actually used, and then the advantages and disadvantages of limb kinematics. So first of all, the definition is it's simply the study of movement in relation to time and space. Specifically, how it's used is we use 3D analysis of sporting action. Okay, and it assesses gait of an athlete. That's their, i.e. their like walking pattern, their running pattern, as well as their movement efficiency as well. So it's used kind of using optical motion analysis really. And as I said, it records an athlete performing sport in action, and therefore, once that is done, it allows the sports scientist to evaluate the efficiency of the movement produced. And here's just a quick picture of limb kinematics in use. So you put motion sensors on the individual athlete, and then on the computer it will show you them in lines here, and we can analyze this now and see the efficiency of the individual's movement patterns. So it could be really good for marathon running, for example, to see what their gait is like whilst running. The advantages of using limb kinematics for the biomechanist is, first of all, it helps to improve technique and therefore performance, i.e. it can be used to help improve running technique for a marathon runner, i.e. heel to toe strike, something I'll go on about in lesson. As well as this, it helps to prevent injuries as well. So 2 advantages there: helps to improve technique, therefore performance, helps to prevent injuries, again helps to prevent injuries via looking at the gait of an individual and seeing potentially what's happening with their gait, therefore we could assess which muscles need to do what in the gym, for example. Disadvantages to using limb kinematics, along with the majority, or if not all, of the biomechanical technologies, it's expensive equipment is needed. Okay, so the equipment that is needed is expensive. Experience is needed whilst actually using this type of equipment. And lastly, is this kind of term here, interreliability. There's poor interreliability of body mark placements. What I mean by this, you don't need to remember all 3 of these. If you can remember 2, fantastic. But poor interreliability of body mark placements. What I mean by this is, if I get an athlete into a gym and I place these body markers on the athlete in said kind of positions here, and then next week I'm away and a colleague has to do it. Now, the reliability of if we're putting them in exactly the same place may be different. I mean, that's going to be poor, sorry. We may not put them in the same places, which straight away means that the information we collate is not reliable. That's all that is meant by poor interreliability of body mark placements. Okay, so that's limb kinematics, definition, assessment, advantages and disadvantages. The other 2 we're going to be looking at are going to be in this format here. Going to see a picture of it as well, so get used to this now, and then please make sure you've got good notes on these so far. Next one is force plates. So force plates, simply ground reaction forces are measured in a laboratory setting or conditions using force plates. That should be force plates, a bit of a typo there, apologies. So what actually happens is the athletes balance, run and jump on a force plate, which assesses their power output. So it actually kind of like assesses the size and direction of forces acting on the athlete's acceleration rates and therefore their power output. However, that as kind of like your information is all you need. So athletes balance, run and jump on force plates, which assess power output. And here is again a picture of a force plate here with an athlete walking on one. You can get them that they're much longer, so athletes can run on them. You also get them where they're kind of put into the ground, so it's exactly the same level as the floor, and you get athletes jumping on them. And what it does is it basically assesses the power output of that individual. So the advantages to this, now the advantage that helps analyse gait. So gait is really important when it comes to efficiency of movement. So again, it helps to analyse the gait, which would help a marathon runner, for example. You're going to get more examples in lesson for each one of these. Helps to measure force produced by the athlete. Okay, so if you're jumping, for example, bilaterally, i.e. right foot and left foot jumping at the same time, it can potentially measure which leg is producing more power. Therefore, in the gym, you know to work on the other limb so that you get it equal to the opposite limb. And it can help improve balance. So if we think of balance, if we think of a swimmer on the starting blocks, they have to make sure they have really good balance to basically make their performance of diving in more efficient. So it's really good to help improve balance of a swimmer on the starting blocks, for example. Disadvantages: specialist equipment needed, and it is expensive, as we've spoken about with limb kinematics. All of this equipment for biomechanics is expensive, and specialist equipment is needed, and therefore specialist knowledge is also needed. Excuse me. Last one we need to be looking at is wind tunnels used to optimize performance. So wind tunnels, if we're looking at a definition, this is simply what are wind tunnels. That they're steel frame buildings, okay, which contain wide fans where artificial wind is produced. Now, the assessment of this, how is it used? This technology is used to develop the drag reduction system. So ultimately, if you think of teardrop helmet in cycling, if you think of F1 cars, these can be tested for aerodynamic efficiency within a wind tunnel. And here's an example of a cyclist using it. So ultimately, you've got wide fans that are acting on the athlete as they're performing, and we can see drag essentially, i.e. this resistance to air. So the advantages to this is it helps with streamlining, thus increasing lift. So it essentially helps to streamline, which is obviously going to make us quicker. It also helps to decrease drag. Disadvantages, as I said, specialist equipment needed, and it is expensive. Okay, so there are your corner notes on this. Please make sure that you have got good details on these, good questions, several questions for each one to really nail technology when it comes to biomechanics in sport. Thank you for listening. I'll see you in lesson.